Hi students, today we're going to learn about trigonometric inverses. Let's start with finding trigonometric ratios using reference angles. So remember, reference angles are just angles in the first quadrant, or reference angles are angles between the degrees of 0 degrees and 90 degrees. So just going to draw you a quick picture. So starting from 0 degrees to 90 degrees, the reference angle is somewhere in this general area, starting from 0 to 90. It has to be between 0 and 90. So let's take a look at tangent of 60 degrees. 60 degrees is between 0 and 90. It is right here somewhere. 60 degrees because 60 is between 0 and 90. So that is the reference angle, and we can draw a straight line down. That will be a triangle. So let's draw it, the triangle like this. If I draw it straight down, this will be 90 degrees. This is the 60 degrees because it was from 0 to 60. Do you remember what that is? 30. So if it's a 30, 60, 90 degree triangle, what are the sides? So remember, across from 30, it is the 1, the 2, and the root 3 triangle. So if you didn't remember that, hopefully you remember the trigonometric ratios. We did this about 2 weeks ago. So what is tangent of 60? Tangent is opposite over adjacent, the opposite side divided by the adjacent side. So 60 degrees is right here. What is the opposite? Opposite is here. Adjacent is here. So opposite is root 3. Adjacent is 1. So your answer will just be root 3. Hopefully this is a good review before we go into inverses. All right, let's try one more. So here's cotangent of 150. All right, let's first draw the unit circle and find out where 150 is. So we have 0, 90, 180. 150 is somewhere between 90 and 180. 180 minus 150 to find that angle, and that will be the reference angle that we're looking for. So 180 minus 150 is 30 degrees. And that angle is 30 degrees, meaning this triangle is a 30, 60, 90 degree triangle. So let's redraw this triangle a little larger so we can see it better. So it's the 30, 90, 60 degree triangle. This means it is the 1, 2, root 3 triangle, but we have to be very careful because this is in the second quadrant. So here x is positive, here x is negative on the x-axis. So that means the root 3 is negative because it is on the negative side of the x-axis. So for the 1, it is still positive because it is above 0 and it is on the positive side for the y. Also in a unit circle, the hypotenuse is always positive. This is a unit circle, and it is always 1, but just know that the 2 is there right now because we are using it as a similar triangle. So the special right triangle 30, 60, 90, we're looking at it as a special right triangle that is proportional to the unit circle. All right, now that we got the picture down, let's go back to our problem. It is cotangent of 150. What is cotangent? Cotangent is adjacent divided by opposite. So the adjacent side to 30 degrees is negative root 3, and the opposite side is 1. So A divided by O is negative root 3 divided by 1. And anytime you divide by 1, it's just whatever it is, so our answer is just negative root 3. All right, so two more weird cases that you might see is when the degrees or radians are on the x or y axis. That would mean that one of the sides or one of the legs, either opposite or adjacent, is going to be equal to 0. So here tangent of negative 180 is the same thing as positive 180, just one side's positive, one side's negative, which direction you're going, but they're the same thing. And you can't draw a triangle, it's just a line. So I would say the height is 0, but the base is 1. So the opposite side is going to be 0, and the adjacent side to that angle is going to be 1. So opposite divided by adjacent will be 0 divided by 1. So that would just make tangent of negative 180 equal to 0. So for cotangent of pi over 2, pi over 2 is 90 degrees on the positive y-axis right there. Now, what is cotangent? Cotangent is the reciprocal of tangent. Here, the height is 1 and the base is 0. So I would say the opposite side is 1, adjacent side is 0, and since cotangent is adjacent divided by opposite, it will be 0 divided by 1. Now, if this is complicated, you could always whip out Desmos. Just make sure you're in degrees mode or radians mode based off of what you're using, and you can just simply type it in. Now, it's easy for tangent, but if you look carefully, there is no cotangent. So what you have to do is use the reciprocal. Who is the reciprocal of cotangent? It's tangent. So you first type in tangent of pi over 2, and then make sure you are in radians mode. If you'll get undefined because there is no answer, and then make sure you divide that whole thing by 1. So 1 divided by tangent pi over 2, this will be 0, and that will mean that cotangent of pi over 2 equals to 0. So let's write this out just so that it's clear. So once again, cotangent of pi over 2 equals to 1 divided by tangent of pi over 2. And we can do this because cotangent and tangent are reciprocals. Reciprocal means you can take 1 divided by the whole thing, or if it's a fraction, you could flip the numerator and the denominator. Okay, let's move on to trigonometric inverses. Trigonometric inverses, you can write it with the negative 1 here. It means inverse, or you could use arc. Both of these represent inverse. You would say cosine inverse of x, sine inverse of x, or tangent inverse of x, or you could say arc cosine, arc sine, arc tangent, and all of these just mean inverses. Now, what are inverses? Do you remember? Just a reminder, inverses are the opposite or the reverse function, meaning you just switch the x and the y value. But when we're working with trigonometric ratios, that means we switch the angle and the ratios of the legs, side legs, and we switch those to find the inverse. Now, just so you know, this negative 1 here for cosine does not mean exponent. It means inverse. So if you wanted to write an exponent for cosine, sine, or tangent, or any other trigonometric ratio, you have to put the whole thing in another parentheses and then put the exponent. So that would mean exponent versus the negative 1 there. It only stands for inverse. Don't get confused. It has no relations to exponents. Now let's take a look at an example of how to use an inverse. So here we have tangent of theta equals to root 3 over 3. So what we can do with the theta there is switch it with the ratio root 3 over 3, meaning I'll write theta equals tangent inverse of root 3 over 3, because when we are working with inverses, we switch the x and y value, or the input and output, and here the input was theta, output was root 3 over 3. We switch those and we could use the inverse, tangent inverse, or if you prefer, you could write arctan. Usually it's just easier to write tangent inverse or inverse of tangent with the negative 1. So if you remember our special right triangle, the 30, 60, 90 degree triangle, you might remember that tangent of 30 is 1 divided by root 3. And if we rationalize the denominator, meaning we multiply the top and the bottom by root 3, we will get root 3 over 3. And now you can see that it's the same thing as what we had for tangent inverse. So that means theta is equal to 30 degrees. Now, if you've forgotten the special right triangles, you can always use Desmos to help you. All you need to do is use the inverse functions. So click on functions on Desmos, then you'll find tangent inverse. Then you type in your ratio, root 3 over 3, and it will give you the angle measurement of your angle, theta. But if you look here, you can see that our answer isn't 30 degrees. That's because on my calculator, I forgot to click degrees. I left it in radians. So make sure you check if you're using degrees or radians depending on the problem and depending what you need your answer to be. Alright, here's another problem for us to try. So theta is an acute angle. Find the value of theta in radians. Let's do it the way using special triangles first, and then we'll do it the way using calculators. So secant of theta equals 2 root 3 over 3. Remember, we can use inverse. So theta equals secant inverse of 2 root 3 over 3. Now, if we remember, what is 2 root 3 over 3? It is the same thing as 2 divided by root 3. Because when we rationalize the denominator, multiplying the top and the bottom by root 3, the bottom will become 3 and the numerator will be 2 root 3's. So they are the same thing. Now what is 2 divided by root 3? Well, 2 is the hypotenuse and root 3 is the adjacent side. And we know this because we're working with secant, which is hypotenuse divided by adjacent. So we know that we can't use 60 degrees. We have to use 30 degrees because root 3 is adjacent to 30 degrees. So we know that secant of 30 degrees equals to 2 root 3 over 3. So theta is 30 degrees. Now let's try using the calculator. So now when I'm in Desmos, I will still make sure I am in degrees first, even though it asks for radians. I will convert it myself later. If not, radians will give you a weird decimal. But as I'm looking in the function section, I can't find secant inverse. There isn't any inverse of secant or arcsecant. So what I need to do is I need to use the reciprocal of secant. What is the reciprocal of secant? The reciprocal of secant is cosine, meaning secant is hypotenuse over adjacent, but cosine is adjacent over hypotenuse. So I could write cosine inverse of 3 over 2 root 3, or if I look at the triangle, I can write cosine inverse of root 3 over 2, which is just the adjacent side divided by the hypotenuse. Now we can actually put this into the calculator. We can either do cosine inverse of 3 over 2 root 3, or we could also type cosine inverse of root 3 over 2. They will both be the same. Just make sure you are in degrees. You will get 30 degrees for both of them, but also make sure that you change it back to radians because that is what the question asks for. So what is 30 degrees in radians? Well, remember from the unit circle, 30 degrees is pi over 6. So your answer, theta, equals pi over 6. Okay, so that's pretty much how you do these problems, but just be very careful. There are similar problems, but read the directions carefully. It might ask you for degrees or radians or rounding to a decimal number, nearest hundredth. Sometimes it might also ask you for between certain degrees or radians, and that's when you'll have to do what you did 2 weeks ago to add 2 pi or subtract 2 pi or add 360 or minus 360. These problems might feel hard in the beginning, but don't worry, just keep practicing and you will be fine.